Solar System, ringed planets. Jupiter's rings were discovered in 1979 by the passing Voyager 1 spacecraft, but their origin was a mystery. Data from the Galileo spacecraft that orbited Jupiter from 1995 to 2003 later confirmed that these rings were created by meteoroid impacts on small nearby moons. As a small meteoroid strikes a tiny Jovian moon, Adrastea for example, it will bore into the moon, vaporize and explode dirt and dust off into a Jovian orbit. This picture is an eclipse of the Sun by Jupiter, as viewed from Galileo. Small dust particles high in Jupiter's atmosphere, as well as the dust particles that compose the rings, can be seen by reflected sunlight. This schematic cutaway view of the components of Jupiter's ring system shows the geometry of the rings in relation to Jupiter and to the small inner satellites, which are the source of the dust which forms the rings. The planet Jupiter has a system of faint planetary rings. The Jovian rings was the third to be discovered in the solar system, after those of Saturn and Uranus. It was first observed in 1979 by the Voyager 1 spacecraft. It is composed of four main components: a thick inner torus of particles known as the halo ring, a relatively bright, exceptionally thin main ring, and two wide, thick and faint outer, gossamer rings, named after the moons of whose material they are composed, Amalthea and Phoebe. The main and halo rings consist of dust ejected from the moon's Métis, Adrastea and perhaps smaller, unobserved bodies as the result of high-velocity impacts. In this wide-field view, James Webb Space Telescope sees Jupiter with its faint rings, which are 1,000,000 times fainter than the planet, and two tiny moons called Amalthea and Adrastea. The fuzzy spots in the lower background are likely galaxies. Saturn has the most spectacular ring system, with 7 rings and several gaps and divisions between them. The rings of Saturn are the most extensive ring system of any planet in the solar system. They consist of countless small particles, ranging in size from micrometers to meters, that orbit around the planet. The ring particles are made almost entirely of water ice, with a trace component of rocky material. Voyager 2 false color image of Saturn's rings. Subtle color variations due to differences in surface composition of the particles making up the rings are enhanced in this image produced by combining ultraviolet, clear and orange frames. The frame was taken from a distance of 8.9 million kilometers on August 17, 1981, 9 days before closest approach, and measures about 68,000 kilometers from top to bottom. Uranus has 13 faint known rings. The inner rings are narrow and dark and the outer rings are brightly colored. The rings of Uranus are intermediate in complexity between the more extensive set around Saturn and the simpler systems around Jupiter and Neptune. This series of images from NASA's Hubble Space Telescope shows how the ring system around the distant planet Uranus appears at ever more oblique tilts as viewed from Earth, culminating in the rings being seen edge-on in 3 observing opportunities in 2007. The best of these events appears in the far-right image taken with Hubble's Wide Field Planetary Camera 2 on August 14, 2007. The edge on rings appear as 2 spikes above and below the planet. The rings cannot be seen running fully across the face of the planet because the bright glare of the planet has been blocked out in the Hubble photo. A small amount of residual glare appears as a fan-shaped image artifact. A much shorter color exposure of the planet has been photocomposited to show its size and position relative to the ring plane. Uranus has two sets of rings. The inner system of 11 rings consists mostly of narrow dark gray rings. There are two outer rings. The innermost one is reddish like dusty rings elsewhere in the solar system. And the outer ring is blue like Saturn's E ring. In order of increasing distance from the planet, the rings are called zeta, 6, 5, 4, alpha, beta, eta, gamma, delta, lambda, epsilon, nu, and mu. Some of the larger rings are surrounded by belts of fine dust. This wider view of Uranus reveals the planet's faint rings and several of its satellites imaged by the Hubble Space Telescope. Neptune has at least 5 main rings and some ring arcs, which are clumps of dust and debris likely formed by the gravity of a nearby moon. Much of Neptune's ring system is quite tenuous, faint and dusty, more closely resembling the rings of Jupiter. The rings are made of extremely dark material, likely organic compounds processed by radiation, similar to those found in the rings of Uranus. The rings are named after astronomers who contributed important work on the planet: Gall, Leverrier, Lassell, Arago, and Adams. Uniquely, the Adams ring includes 5 distinct arcs, named Fraternité, Égalité 1 and 2, Liberté, and Courage. The arcs occupy a narrow range of orbital longitudes and are remarkably stable. Webb Space Telescope's near-infrared camera, NIRCam, image of Neptune, taken on July 12, 2022, brings the planet's rings into full focus for the first time in more than 3 decades.